Okay, I showed a little of my decimals that came out, so if you want to check them against yours, I got 4.25, so I'd like to compare that to your number. Alright, so let's go back to that range we had earlier, lower and upper sums. That number 4.25 falls right in between there. So turns out that area, I happen to know the area under that curve is 4 units. So even with 4 subintervals, we got 4.25 with the trapezoidal sums. That's pretty decent, having only 4 subintervals. So if we went to 8, I'm sure it would zero into 4 quite nicely. And the midpoint boxes gave us 3.87, almost 3.9. So not too shabby. If the true answer is 4, you can see that we're doing a pretty good job. All right, we'll end tonight with, I think I accidentally gave one of you the answer key to color. That's all right. Go ahead and color the answer key. The rest of us are going to fill in the answers. And we're looking at Riemann sums. And after tonight's lesson, you can see the answers, subinterval, n equals 7, interval, Bernard Riemann. So that's the name of the guy who came up with it. Change in x and height will make sense in those spots. N is the number of intervals or rectangles, and the height of each one is when we put the values into the function, and that's the width of each one. So I said the more boxes, the better the approximation. So here we are adding up all the boxes, heights times widths. Our interval is the width of each one can be found by this number minus this number divided by n, which the simple cases we've seen, it was 2 minus 0 divided by 4. So each of our boxes was 1/2 wide. Subintervals or rectangles, here the number is 18, so we're going for a much closer approximation when n is larger. And here's an important point. With more rectangles or subintervals, the approximation of the area becomes more accurate as n approaches infinity. So believe it or not, that'll be our next adventure with our Riemann sums. So we will be approaching infinity. Here's an example. And when we get to class, if you haven't done that already, you can work on that in class. That will be one that I can assign. Feel free to work on it at home. And the function is given. Function is negative x squared plus 5. So we're going to do just what I did tonight with y equals x cubed. And we'll start out with that one. And it's going to be similar to their work right there. So which kind of boxes are they? They're doing the right Riemann sum. So a right Riemann sum will, in this case, cause an underestimate. And then we were asked at the very end to draw in the left boxes. So that's kind of confusing because you haven't done each of these steps yet. But we'll do that together, or you can do it ahead of time if you know what you're doing. All right. All right, and then just color it in. Just put some color on that page. All right. That's it for this multi-segmented teaching on Riemann sums and trapezoidal sums. So I will see you on Tuesday. Till then, goodbye.